All right, powerful peptides. That's our video today. What are peptides? Well, we'll talk about what peptides are. In simple terms, right, you have amino acids. They're the basic unit of a protein, and they'll form a chain of amino acids. A short chain of amino acids is a peptide, and then as it grows, it could form a protein. So let's get a picture of that. All right, you see the picture here. So our body makes 11 amino acids, but we still have to get 9 more. So we have 11 amino acids, and they're called non-essential even though they are essential. They're called non-essential because the body makes them. So you don't have to get them from food. That's the only reason. And then there's nine amino acids that we have to get from food. They're called essential. Now, again, they're all essential. They're all vital. We need all 20 of these amino acids to make peptides and to make proteins. Proteins have a major function in the body. Everything you can think of that your body needs comes from proteins. Anyway, I have videos on that. But let's see how this is done. Just quickly again, I have transcription and translation videos. But in transcription, which is the first process, an mRNA molecule, mRNA will code a gene to make a peptide or a protein. It'll code it in the nucleus. And then when it leaves the nucleus, it's going to look for a ribosome. And in the ribosome, it's going to code for a peptide and a protein. That's called translation. So let's get a picture of that. All right, and you can see the mRNA entering the ribosome in the cytoplasm. So here it is. Powerful peptides came back up. They want you to be reminded. Let's go back. All right, let's try it again. So here is right here the mRNA, the messenger RNA that left the nucleus with this code. And they're carrying with them these nucleotide bases. We have 4 bases in the nucleus, right? We have adenine, we have thymine, guanine, and cytosine. And they will match each other. Adenine will always bond to thymine. Thymine again with adenine. Guanine with always cytosine, and so forth, right? This is always going to happen. And every single animal on Earth has these 4 bases. But there's a 5th base, uracil, U. And thymine doesn't leave the nucleus, so it's replaced by uracil. As you can see here, see these U's over here, because it replaced uracil. And so instead of adenine bonding with thymine, it will bond with uracil. Now, as the mRNA goes into ribosome, it's going to call upon tRNA. tRNA is going to bring a anticodon, as you can see here. So every 3 nucleotide bases, 1, 2, 3, every 3, as you see here, is called a codon. And they'll code for a certain amino acid. The tRNA is going to bring the anticodon, the opposite, and with it, it will bring an amino acid. So over here you can see it says UUC. Well, we know that A bonds with U outside the nucleus, A bonds with U, and G bonds with C. So UUC is entering the ribosome, UUC, and there's its anticodon bringing with it its amino acid. And as it keeps going in, you can see this peptide chain growing. Now it's either going to be a peptide or it's going to be a protein. So it's this protein factory that's occurring. Now let me clear this up. Find my eraser there. Clear this out, and let's see if you're getting this. So let's say the next codon here, it's CAA. CAA. What do you think the anticodon would be? What do you think? So we have CAA. What will it bring? Well, it'll bring G. Should get a better color than that, right? It'll bring GUU. That'll be the anticodon. And as the tRNA bring that anticodon, it will also bring with it an amino acid. So if you wanted more information, you can look at the transcription, translation videos I have. In the meantime, let's get back to these powerful peptides, very essential. Hormones, which are chemical messengers, very essential for our body. Well, they're peptides. And we'll look at a few. Well, you know one, I'm sure you know, is insulin. That is well, some people will say it's actually a small protein because in peptides, they're a short chain of amino acids, and some scientists might say the definition of a peptide right up here, so when does it become a protein? It's 50 or less amino acids. So if you have 50 or less amino acids, you can be considered a peptide. But insulin has 51 amino acids. So technically, it's above a peptide. It's a polypeptide. It's a small protein. So poly means many. And insulin, of course, it regulates our blood sugar levels. Without insulin, of course, we couldn't get that glucose to our cells. Let's look at a few other. There's glucagon. Very fancy word. Now, glucagon is like the anti-insulin. It opposes insulin. It raises blood sugar levels. So when sugar levels come into the body, insulin is trying to get that sugar into your cells. Now, glucagon, what happens with this is the liver stores glucose. So if any excess glucose that your cells don't need, that insulin knocked on the door of your cells, it let in the glucose, any excess glucose will be stored in the liver, and they'll store it as glycogen. Right? And so you have this glycogen in the liver. So anytime you need sugar, let's say you're fasting, for example, you need energy all the time in the body. What will happen is the pancreas is going to send out glucagon to tell the liver, and I'm doing it in simple terms here, to tell the liver that we need more glucose. So then the liver will take the glycogen and make glucose with it. That sounds a little complicated, right? And I'll review it. It's not that hard, actually. So glucagon has 29 amino acids. So it clearly falls into the realm of being a peptide. Now, again, there's another word I said. Glucose, we mentioned a lot of G's here, right? We have glucose, which is the sugar that the body prefers. And when glucose is stored in the liver as glycogen. But when the body needs to use glucose again, it needs to break down the glycogen in the liver, and it needs a signal. Again, hormones are chemical messengers. So the chemical messenger is, you got it, glucagon. So it tells the liver, hey, take that glycogen you have and turn it back into glucose. Let's look at another one, ghrelin. Another G throwing up today, right? Ghrelin is the hunger hormone, right? It's the hunger hormone. Right? It stimulates appetite. That's what ghrelin does. And just one less than glucagon, it has 28 amino acids. Right? 28 amino acids. So it definitely is a peptide. But now you have this appetite with ghrelin. Well, something has to tell you that you're satisfied, that you ate enough, that you have this fullness. And that's leptin, another hormone. But leptin is clearly a protein because leptin has 167 amino acids. 167 amino acids. Clearly a protein. But there's more, right? There's vasopressin, for example. Vasopressin has 9, so it's very short. Vasopressin. Not a protein. Well, let's write that down, actually. Let's clear some of this out. We'll write down vasopressin. So vasopressin, again, is It's a hormone that regulates water balance and blood pressure, vasopressin. And it's very small. Again, 9 amino acids. 9 AA, we'll say AA amino acids. Alright, here's a ghrelin. Sometimes it's pronounced ghrelin, actually. Many people say ghrelin. So let's just say, again, the hunger hormone, right? Gives you that appetite. And as you can see, here's the chain, right? It has 28 amino acids. And there's the first one, the G over there. That's glycine. That's amino acid right there, glycine. And it disappeared on us. Let's fix that. Alright, so it's back. So there's... and it goes away again. Well, let's see. Let's see if it works this time, right? So ghrelin, the hunger hormone, as we see here, it has 28 amino acids. There's glycine. There's an amino acid, glycine. Should use a better pen. Glycine over there. Right? There's serine, another one over here. There's a modified serine over here. And phenylalanine is actually pronounced PH, but the symbol is F. So you can see all these amino acids together will build a peptide ghrelin that we need to give our appetite. Now there's other peptides that we get. Again, peptides are made from amino acids. 11 are made in the body. 9 we have to get from food. Those 11 are called non-essential, even though they are essential. And the 9 that we get from food are called essential. And together they'll make peptides, short chains of amino acids. And if we keep going, longer than 50 chains of 50 amino acids, you'll get a protein. Alright, that's our video today.